What's up guys, and welcome back to another video. I'm the Cubophile, and today we're going to be learning to solve the Square-1. Surprisingly, despite how complex it might look, there are actually no prerequisites you need to know in order to solve this puzzle, although learning to solve the 3x3 can come in use for some parts, so if you still need to know how to solve a 3x3, you can go check out my tutorial, or just learn from anywhere, but it will come in use here. This video will be a beginner's method, so we're not going to use any fancy algorithms that the professionals use. We're only going to be using the most rudimentary of algorithms, and I'll try to explain them the best as I can. And yeah, without further ado, let's get started. Before we actually get started solving the puzzle, you should of course first know the notation. And so, in the algorithms, this is what we will be using. So, in an algorithm, a slash means a slice turn. So just like how I did here, it means, it's really quite intuitive, just gripping this right side here and just turning it 180 degrees such that white and yellow will always be on the top and bottom face at all times. That's pretty intuitive. And then between every slash, you'll see what looks like a pair of coordinates, which in this case represents how many times we have to turn the top and bottom layers. So I'll put an example on the screen. Let's say for -5. So this is what we'll do. So the first number represents how many times we turn it on the top layer, and 4 means we'll do it 4 times, and it's best to show you what that means by just doing it. 1, 2, 3, 4. It just simply means how many of these crevices and these protruding points we count. We count those as moves. So 4 goes that way, and then -5, remember on a 3x3, D prime and U both go this way, so a positive and a negative will both go the same way here. So -5 on this will go 1, 2, 3, 4, 5, and that's 4, 5. Because of the way the Square-1 works, it works in such a way that it's a shapeshifter, which means that you can take it out of a cubic state, which in fact is the first step to get it back in such a cubic shape. The best way that I go about this is first thinking about these edges here. We call these edges and these corners. Think about these edges in groups of 2. So first you want to group two pairs of edges together. So you want to have 4 conjoined edges. So here we have already two edges made, and here we have 2 edges made. So the first step would be to connect them. So this should be pretty intuitive. You want to align the layers in such a way to turn it, and you might not be able to align them immediately with one turn. You see we can't do it here because we can't turn it. This is in a straight line. But if we put it here, then we can do a turn, and then just orient some things a bit, and then eventually you'll be able to get it. Something like that. So now we have 4 edges paired up, and now instead of just making 4 edges, we only just want to make 2 edges, or 1 pair of 2 edges. So that's also, again, pretty intuitive and pretty easy. There aren't any algorithms. That's just use your intuition about how to turn to figure it out. So I realize I can pair this one with maybe this one here. If I align this layer down here, then bring it up, I made a pair of 2. And then after that, after you made a third pair of 2, conjoin it to your your group of 4. So again, you might not be able to do it immediately, but just do a few turns and you'll get it like so. I should point out though that it actually doesn't matter the arrangement of the colors here. It just happens to be white here and yellow here. It could be white, yellow, white, yellow, white, yellow. It could be yellow, yellow, white, white, yellow, white. It doesn't matter, just have them in a group like this. And from here, you have 3 possible cases, and we're going to be showing them now. And for this one, you are going to need to know algorithms, so keep in mind what we learned at the beginning. This first case is when you have your 6 grouped up here, and then the 2 edges remaining on the bottom are in this shape. They're in a straight line, and they just look like this. You'll just know what they look like. So this one, actually, you don't need to know an algorithm. It's fairly straightforward. You just move these all to the right side, and move this to the left side, and then just do a slice move. That's basically it. And then you have the tulip shape. That's what we call this shape, the tulip shape, which is your end goal for this step. The next case is this one, where you have your group of 6 and the 2 edges remaining are in an L shape, so not in a straight line, but like we had before, but like this. And so this step is also pretty intuitive, but you can learn it like an algorithm if you want. You replace this top part here, like so. like you take out a group of 2 edges and replace it with this shape here. Then with these group of 2 you just took out, you want to replace it, just adjoin it to these 4. So you want to imagine taking out this, like so. So you have a group of 6, but now you went back to the first case we had, which is just having two straight edges here. And then that's just also pretty intuitive. You just do a slice move, and then boom, tulip shape. And then the final case is when you just have 2 of them already paired together. You have 6 and then 2. And then, I mean, this is just incredibly easy. You just attach them like that, and then tulip shape. So in all 3 cases, you'll end up with a tulip shape on the front and something like this, a star shape on the bottom. And then from this, you want to do this algorithm to get into a cubic shape. Slash, -2, -4, slash, -1, -2, slash, -3, -3, slash. And then just like that, we have cubic shape right here. Between each of the steps, especially this one, you might be like, oh, why is this one? This isn't cubic shape, this is messed up. This is something you might encounter between every few steps, and usually the professionals just leave it until the end, but for our sake, we'll just learn this simple algorithm. If it bothers you and you want to take care of it, it's just like this. Slash, -6 or +6, slash, +6 or -6, slash. And so either way, those do the same thing. Those just get you into an entire cube shape, and at the same time, flip this layer. So this might very well be the easiest part of the Square-1, which is corner orientation. So it's, again, pretty intuitive what we're doing, orienting the corners. So split it up into 2 bars. That's how you want to think of it, 2 pairs of corners. So here we already have one set of corners, or however you want to think of it, yellow, yellow. So we want to create another bar of yellow corners. So one's down here, one's down here. This should be pretty intuitive. So move this down to pair up a bar of 2, because this is bottom right, bottom left, however you want to think of it. So you pair it up, and then move it in such way so that if you bring it back up, it's aligned with this bar here. So make sure it's not in the way when you bring it back up, and then you'll just have all corners oriented. Next up is edge orientation, which we finally solve all the yellow, make this side entirely yellow and this side entirely white. And so this is the algorithm you have to know, and the way to set it up is to put 2 edges that need to swap on the right hand side here. So for example, you want to switch this white and this yellow, so you put them like this. You don't want it like this, or you don't want them in another direction like in front of you like this. You want them like this. Pretty intuitive. And you want to do this algorithm. 1 slash -3 on the down side. 1, 2, 3 slash -3 slash -1, -1 slash 1, 4 slash and 1, 2, 3 slash. And so that just swapped 2 edges, as you can see. And then you'll go basically doing like that around the cube until all the edges are solved. So that swapped 2 edges. If you remember, like, if you should remember, just we had two edges messed up on each one, so we'll just do that algorithm one more time to just swap those 2 remaining pair of edges, and then we've just solved or completed this step. So although that last step was technically called corner orientation, this is also corner orientation because we're going to be solving these ones on the outside here. And the setup for this is that you either want headlights or a bar. And if you watch my 3x3 tutorial, you know what this means. A bar is just simply 3 colors in a row here. And headlights is here with 2 different colors and 1 color, or 2 colors sort of the same, and 1 different color in the middle, like so. That's headlights. In either of these cases, you want to put it in the back and do this algorithm. Slash 3, -3, slash -3, slash 3, slash -3, slash 3, slash. And that solved the corners on this side here. And then if you just have a case with no bars or headlights, you just do the algorithm twice. So you just do it normally the first time. And then you'll definitely have a pair of headlights or a bar at this point. So again, just put that to the back and do that algorithm. And now it's time to introduce a little bit of a different algorithm that helps you switch the sides here. And you'll understand what that means in a minute. So this is the algorithm. 1, -1, slash 6, -6, or whatever combination of sixes, and then slash. So now you just see we did nothing, but we have white on the top and yellow on the bottom. So often we want, if you're looking from this perspective, you'll see a short and a long, and here short and a long. So if you have it like that, then you want yellow on top and white on the bottom. If you see long, short, then you want white on top and yellow on bottom. But often when solving it, we'll have yellow on top because that's just convention. So we're just gonna flip that back. And if you ever find yourself needing to, so the algorithm we just did, you could either do this algorithm to do the same thing to the white side. As you can see, we have a bar here. So we move that to the back, do that same algorithm. Or if you don't want to do that algorithm, you can just flip it over and do the same thing. It really doesn't matter. You just do like that, go exactly the same way. But however you want to do it, you should eventually end up with all the corners solved looking like this and have something like you'll see on a 3x3. You'll know that it's something like a U-perm or a Z-perm or an H-perm. But the algorithm you want to learn to solve this and plus the setup is we're going to solve 2 edges at a time. So this algorithm is going to swap these 2 edges and these 2 edges, or these 2 edges and these 2 edges. And so you want to set it up in a way such that they need to be swapped. So for example, red and blue need to be swapped here, and green and blue will need to be swapped here. And eventually you'll use intuition to know why we want to swap these 2 and not these 2. So move these 2 over to the side to be aligned like this. These 2 need to be switched, and these 2 need to be switched. Hold them like this, and do this algorithm. -2 slash 3 slash -1 1 slash -1, right, sorry, 1 -1 slash, and then just whatever realignment you have to do, and that swapped these 2, and that left us with 2 more pairs of swaps, which again you just want to go ahead and repeat, set them up on top of each other like this. These 2 and these 2 need to be swapped, and do that same algorithm. And that just solved the cube. So we are done with solving the cube, except there's one last algorithm that we have to do for a special case. But before we get to that, I want to go ahead and explain how to actually learn the Square-1, because I've heard a lot of people talking about how they're reluctant to learning because it's like very hard, the algorithms look very hard, it turns very hard, but in reality there's a very simple way to learn how to solve it. And that key tip is to learn visually, because like me and probably most other humans, we are all visual learners, which means instead of a whole bunch of numbers to memorize, learning it like say you're on a trip and memorizing landmarks is going to be much easier. And I felt like what better way to demonstrate that than through the parity algorithm, which is what this is called. We have 2 swapped edges here, nothing to swap on the bottom, so just swap 2 individual edges. And that on the screen is the algorithm for this case. Look at that. That is disgusting. Nobody wants to learn that, and that's what originally put me and quite a few of the people I know off of learning it, but it's very simple once you get used to it. So this is how I learned it. So the first part with the 3s, I find that pretty simple, and it also relies on muscle memory. So once you do the algorithm a few times, your hands will know where to go and just how to turn it. So the 3s, my hand knows how to do it like... That part is really ingrained into my mind, so I can just naturally do that part really fast. And then the rest of the algorithm, you just move that a bit, I think of it, slash, move that a bit, slash, and move that a bit, slash. And then you'll have something like this. So 1, 2, 3, 4, 5, 6, 6 pieces here. You want to bring over this side here that's right over after the headlights, this part here right after the different piece, move that there, slash. Then you'll have some rounded thing on the center right here. So first you move it to slash, move it back to slash. And then I just remember to move that barely and to move this a whole bunch. Or move it a whole bunch the other way, sorry. Or, no, I was correct the first time. Move it like that, a whole bunch the other way, like that. And then move this a whole layer again. And then just realign that. And then just like that, that's how I learned the parity algorithm. Oftentimes you'll end in this case, but we already covered this, just do the algorithm on the screen. So what we just did with this algorithm, instead of just learning all the algorithms I mentioned throughout the video in just their normal format, I recommend learning it like this, or the algorithms, some of them are too short to like bother learning by memory, or by visualization, but it'll mostly come in muscle memory once you do it a few times. It's very fast. Like for example, some of the algorithms you'll do like this. Once you get them ingrained, your hands will just do them naturally. That's what muscle motion is, or muscle memory. Sorry. And then yeah, that's how you learn it. And that'll be it for this tutorial on how to solve the Square-1. Of course, I hope you learned something out of this video, and if you did, go ahead and like and subscribe down below. It really helps me out a lot. And yeah, if you want me to make a further in-depth tutorial, then just leave it in the comments down below, that also. And until the next video, peace.